So picking up on the back of the sine cosine worksheet, I'm going to start with number 3. As I said, it looks like I've done 3 and 6. Not saying 4 and 5 are bad problems, it's just we have to decide how many examples do we want here. So I shouldn't say we, it's really my choice, but you know. Okay, so number 3. My recommendation on these is always start and go through and list some information, right? Kind of pull everything together. So what kind of pieces of information can you tell me about number 3? Okay, center line is one of the first things we looked at. And when we talk about the center line, if you flip back, you're going to have to flip back and forth to the front side and the back side. It is the plus D. Well, plus D is a number added or subtracted at the end. What is our D value here then? There is none, so it's 0. So that just goes to say that our x-axis is still 0. It's not going to move up or down. Okay, what else besides center line? Okay, we usually talked about amplitude. And amplitude, it's a letter A, right? Okay, it's whatever number is in front of sign. So what's in front of our function sign here? An invisible 1. So our amplitude is 1, which if you remember amplitude, that is how high or low your graph goes. Okay. After we talked about amplitude, we usually talked about the period. In order to find the period, it's 2 pi divided by b. Where do we find b? The coefficient of x. So the number on x, which in this case is 3. So this says that one cycle of our graph is going to fit in 2 pi over 3, in the distance from 0 to 2 pi over 3. So this is one cycle. So this graph is definitely shrunk. Okay, horizontal shrink here. What else do I need to ask? Phase shift. Yesterday, I don't know if it was this class or my other class, I even forgot to ask about phase shift once because in my head I knew it was, non-existent. Anytime you have a plus or minus number in the parentheses, we need to talk phase shift. And the phase shift, is it C over B? Is that how it's listed? Okay. C over B. What would be C over B? Okay. And this is where we're in the parentheses. So we're actually going to go with the opposite sign. Okay. So since our original form, if you look at the form, it is bx minus c. If there's a minus sign there, we just grab the pi. And so this is going to be pi over 3. It's opposite that middle sign. Just like horizontal shifts normally, it's opposite the middle sign. And so this is going to be pi over 3, and we're going to move our graph right because it's a positive pi over 3. Now, if that's a little confusing to you, here's another thought. If you're confused on how to remember the sign, take whatever's in the parentheses and set it equal to 0. So, and solve it. So what's in my parentheses here is 3x minus pi. So if I take 3x minus pi and set it equal to 0, you would first have to what? Add pi over. So you have 3x equals pi. And then you would divide by 3. And so you would have x equals pi over 3. That kind of confirms that, yes, my phase shift is a positive pi over 3, meaning we're going right. Yes?
So if it was a negative pi over 3, just do left.
Yes.
Like if it was 3x plus pi.
If it was 3x plus pi, we would use it as a negative pi over 3, and we would be moving left pi over 3. Yep, it's just like horizontal always is, opposite the direction of the sign. Okay? Okay, and the one thing, let's see, we didn't address reflection. A reflection would have happened if there was a negative out front, no negative out front. And what is this I'm graphing? I'm graphing sine. What's sine look like? Okay, mountain followed by a valley, right? So that is our shape of sine. Now, I'm going to tell you guys, our labeling has to kind of be totally different here. We'll still start with center line amplitude, but how we set up our horizontal axis is different on this one. So center line is 0. Either put the 0 here at the left or by the origin. Amplitude is 1. So I'm going how far up and how far down? Up 1, down 1. So, and you can label those up as high and low as you want, but label them. Don't just put the marks. Actually put numbers on them if you want to get the credit. Okay, I need to see the numbers. Okay, what is our period? 2 pi over 3. You'll learn real quick. These are the ones we really have to stop and think about, because all of a sudden, even though we need to take our sine or cosine graph and we think about it in 4 sections, we have to talk about something in thirds. Okay? When you think 2 pi over 3, if we think thirds, yes? What I would recommend doing, since this is 2 pi over 3 we have to talk about, is I would start by labeling my graph in thirds, and then we'll go from there. So if I'm labeling my graph in thirds, and it's a cycle of 2 pi over 3, keep in mind we also are going to have to go pi over 3 right. So what I'm going to do on this particular problem is I'm going to label out to pi. Okay? Instead, yeah, sorry. It's a little bit maybe past middle, but yeah. I mean, you could put pi all the way out by the right arrow. I mean, if you do that, as long as it is labeled, it works. Okay? So there's pi. Now, normally I would say, okay, let's break this into fourths, right? Break it in half, then break those halves. But we need to start by having our appropriate labels of thirds. So what do you know about 1 pi? It can break, we can have 1 pi over 3, 2 pi over 3, and 3 pi over 3, right? So maybe I should have had you label your thirds instead, but break this in to thirds is what I'm saying. So that I have 1 pi over 3, 2 pi over 3. Or if you want, what I maybe should have said from the beginning is just label 1 pi over 3, 2 pi over 3, and 3 pi over pi. 3 pi over 3. You know, make them equal sections. And here's the key. Do mine look equalish? You know. Not the type of getting the ruler out and checking equalness, but do they look approximately equal? Okay. On these, what is our cycle? Our cycle length is 2 pi over 3, right? So one sine curve has to fit between 0 and pi over 3, yes? Okay, now if you notice right now I only have, this is only split into 2 pieces, right? So I would encourage you to now split it, those 2 pieces into halves. I'll be honest, I will often let you get away with just putting the marks in between them and not necessarily labeling them once we get smaller. So if you just want to put marks in between those to represent there, you can. Now, if I put marks in between those 2, what else should I do over here? You should have a halfway mark. Now, okay, let's talk about it, though, for a moment. What is the halfway mark between thirds? What's a half of a third? A sixth. So these, technically, if you were labeling them, this would be 1/6. 1/3 represents 2/6. This would be 3/6, or 1/2. This represents 4/6. This one would represent 5/6. And this puts me at 6/6, right? Okay, so when we get those middle marks, depending on the situation, you can sometimes get away with just putting a little tick mark to represent. Does that work? Okay, so what I tend to do here is I tend to take a pencil and lightly trace in before I do the phase shift. Okay, so I kind of like do a dotted line. My graph has to be between 0 and 2 pi over 3. Make sense? So I need my whole sign to fit between 0 and 2 pi over 3. Not going past that point. Now, typically, what's sine do? It starts where? At the origin at 0. And as we do this, notice, do I have my 4 marks? Yeah, at the first quarter mark, what happens? We're going to have a max. Then what happens halfway through the sign? Halfway through, you cut down through the midpoint, which is pi over 3. Then what? Underneath the next middle piece, we have a minimum. And then at your ending point, what's my ending point on this one? 2 pi over 3, you would have a 0. Now, as I said, I just did that in pencil, dotted line. I'm making it a little darker just because, can you guys see what I did? Okay, that's not my final answer though. Because we had a phase shift. So now, we have to take each of those pieces we just did and move them pi over 3 to the right. What is pi over 3 on this particular graph? It's one whole big tick mark, right? Or it's 2 little tick marks if you look. So instead of starting my graph at 0, when I shift it pi over 3 right, where's it actually going to shift? It's going to start at pi over 3. Okay? I did have a max over the next middle mark. So now my max is going to be over the mark between pi over 3 and 2 pi over 3.
So is it going to be just not pi 1?
We're going to keep going the whole thing. Okay? So now, originally my graph then cut through at pi over 3. Move that right pi over 3, and now where am I cutting through? 2 pi over 3. Then I have a minimum. And finally, my graph was supposed to end at 2 pi over 3. So now it's ending at pi. Every single mark moved over 2 tick marks, or a pi over 3. Just like yesterday, I just put those 5 markings in to help me connect my graph. Does that make sense? And keep in mind, this graph technically keeps going, doesn't it? It doesn't just stop there. There's arrows, it keeps going. But in terms of one cycle, that's what I'm grading. Questions I can answer here.
Do we only do rabbit though? Do you want us to always put the dash one first?
That is a personal decision. I think it is helpful to put the penciled in original first to kind of see what you're doing. Some people will, some people won't as we go along. Okay? And here's something to check, guys. My period was supposed to be 2 pi over 3. Did one cycle end up fitting in 2 pi over 3? So what do you know about pi over 3 to pi? Is that a distance of 2 pi over 3? And it is a distance of 2 pi over 3. So that's all good there. Okay. Questions on that one? Okay. Let's go down and try 6. Why do you think I'm trying 6?
I don't want to do
It also has every other thing, so you're not doing all of them.
We'll see how time goes.
I think we should do 4.
I prefer 6 because I like to
Okay.
That's true.
We can do all of these. It's just a matter of how we want to work our time. This worksheet is due tomorrow. Period. End of statement. Okay. Okay. Number 6. Let's do it.
Okay.
Center line.
-1.
Center line is the number added or subtracted at the end, which is -1. If you want me to go ahead and put the -1 on my graph? There's my center line, -1. We usually next have been talking about amplitude. What's my amplitude?
-3.
The number out front, the absolute value of the number out front, which is 3. So that amplitude of 3 means we're going to go as high and low as 3. So if my center line is -1, what does that mean? Up 3 from -1, which puts me at what? 2. Okay, because -1 plus 3 is 2. And then if I go down 3, -1 minus 3 is -4. Now, some of you tried to tell me a negative amplitude. It's not really a negative amplitude. It's what? The x-axis. Now, with that in mind, what is it that we're graphing? Okay. Normally, cosine is a big old valley. Our cosine is going to be a mountain instead. We're going to start low, go high in the middle, come back low. Okay? I can't really draw that on right now, so I'm kind of done drawing on the graph for the moment. What else?
Period.
The period. How do we do period?
Each bar would be 1 pi.
2 pi over b.
Oh, okay, I'm sorry. Okay.
Well, it's 2 pi over b. What is b? 1/2. So it's 2 pi divided by 1/2. So when we divide by a fraction, you're multiplying by the reciprocal. So when I say 2 pi divided by 1/2, what my brain really needs to say is 2 pi times 2. And 2 pi times 2 over 1 is 4 pi. So one cycle is going to go in 4 pi. So the last one we did, we shrunk it in. This one we're going to really spread it out, which is, my graph is limited in size, so it all comes down to labeling. And last thing we need to make sure we mention, phase shift. So phase shift is C over B. Use the opposite of the sign, though. So what is C over B? negative pi over 4 over 1/2. So negative pi over 4 over 1/2. Well, didn't we just divide by a fraction a moment ago? So divide by a fraction again. It's going to be negative pi over 4. Dividing by 1/2 is multiplying by 2 over 1. So that is negative 2 pi over 4, which is going to reduce to negative pi over 2. And since it's negative, that means we will be moving left. Okay. Go back to your period to think about how we want to start labeling. I kind of label for the period, and then I take in the phase shift after I kind of think about the period here. My period is what? 4 pi, which means I have to label a minimum to 4 pi, right? I mean, in the end, I'm going to end up going left pi over 2, so I'm going to label to 4 pi, okay? Which is actually nice labeling if you think about it. Okay, if I use my whole graph for 4 pi, again, sine, cosine, I want you breaking it into fourths. What's the middle of 4 pi? 2 pi. I'm trying to make this easy. I don't know if I'm succeeding, but. So now I have halves. Now take each half, and break those up. So what's the middle of 0 to 2 pi? 1 pi. What's the middle of 2 pi to 4 pi? 3 pi. Kind of worked out nicely, didn't it? Sometimes they work out ugly, like the last one wasn't exactly pretty. Sometimes they work out beautiful. I like that. Okay, now, we could think about this a couple of different ways. We could go ahead, because here's the deal. We can go ahead and draw what our cosine curve looks like, but then we're still going to have to shift it over, right? So, when we shift it, we're going to shift it pi over 2. The only problem with my beautiful labeling is I don't have any pi over 2's here. Where is pi over 2 in relation to the labeling I do have? Yeah, because right here we have whole pi's, right? 1 pi, 2 pi, 3 pi, 4 pi. Pi over 2 is half a pi, and so that pi over 2 is in the middle, yes? So if that's where my pi over 2 marks are, what do I need to put in the middle of each of these marks? You're going to have the halfway points marked here. Okay, you're going to have the halfway points marked. Now, you can just put the tick marks in like that if you want, because as long as you have other pieces labeled, I'm good with it. Or you can go through. This is 1 pi over 2, or pi over 2, pi. This would be 3 pi over 2, 2 pi. This would be, what's 2.5? 5 pi over 2. 3, what's 3.5? 7 pi over 2. Now, keep in mind we're going left. So what is the one other thing I need to add on? We're going to have at least one tick mark, and this is where I say make them equalish in size. I'm going to go ahead and put negative pi and negative pi over 2. Try and be equalish to what you already did on the other side. Again, I'm not getting the ruler out, I'm just eyeballing. So if I put these, 3 pi over 2, 5 pi over 2, 7 pi over 2. Okay, remember, what were my original marks? 1 pi, 2 pi, 3 pi, 4 pi, right? Okay, I'm going to try and zoom in so we are focused on the graph because that's what's important. Okay, I'm going to start my pencil version. without a phase shift. So we're doing a reflected cosine. Cosine normally starts where? Up top. Since this is a reflected cosine, it's going to start down low. So I'm going to start down here at -4. Now, remember, and this is why maybe I shouldn't have gone ahead and put the halves on there yet. Our quarter marks are 1 pi, 2 pi, 3 pi, 4 pi, right? So our first quarter mark is 1 pi. What am I doing at 1 pi? If I started low, I'm cutting through. What's the next quarter mark I need? 2 pi. And what am I doing at 2 pi? I'm going to have a max. What's the next quarter mark? 3 pi. What am I doing at 3 pi? I'm cutting through. And my final quarter mark is at 4 pi. And what am I doing at 4 pi? I'm going to have a minimum. And this is where to each their own. Because some of you are saying, okay, now what? Some of you are saying, that was a waste of my time. Why didn't we just do the final graph? Some of you cannot survive without me doing this, though. That's why I did this. So for those of you out there saying, Mrs. Sargent, really? That was a waste of time? It wasn't for some people, trust me. Okay. What do I do with everything I just did? Shift it left pi over 2, right? So instead of starting at 0, -4, I'm starting below -pi over 2. Instead of cutting through at pi, we're going to cut through at, we're just moving everything 1 left. Okay, so we went 1 left here, 1 left here. My max was above 2 pi. Now it's going to be above 3 pi over 2, or the mark in the middle of pi and 2 pi. I cut through at 3 pi. So if I did cut through at 3 pi, now I'm cutting through at, it's 5 pi over 2, the mark before it. And I did end below 4 pi. Now I'm ending below 7 pi over 2. And I feel like I ended too low underneath that 4 pi. Yikes. Hold on. I don't want to interrupt the process here. Okay. Now, connect those. So now we're kind of ignoring the original. And it should kind of look like a, I mean, you see a relationship, yes? It's the same mountain, just shifted left. Okay, question.
When we cut through that y-axis, though, starting on that -pi2 and that 4, does it matter where we cross through? Because we crossed through -3 and -4. Does it matter where we cross through?
Oh, on our final graph?
Yeah.
No. I mean, we don't have an actual physical, this is precisely where you should be crossing through the y-axis. So, just make it look appropriate. I won't judge that. I will judge, okay, did you start at a minimum below -pi over 2? Did you cross through at pi over 2? Is your max above 3 pi over 2? Did you cross through at 5 pi over 2? And is your minimum below 7 pi over 2? Okay. And even if you just had those marks and didn't have them labeled, are you in the right spot? Now, we can go pick another one to do, or you guys can start working on the worksheet while it's fresh in your mind and seeing if you can make some of these happen. As I said, I'm not going to do all 6 of these at the beginning of class tomorrow, but I can answer some questions. Okay? But it'll kind of have to be a classroom agreement because I'm not doing a bunch of them.
Is it due tomorrow?
It is due tomorrow.
They don't really seem that bad. There's just a lot of things that, like, you forget one.
I feel like I'm going to be graded more on my artistic building.
No. I'm not going to.
I don't have a penis
I'm not. Yeah. I am not graphing based on, how pretty your curve looks. Okay? It's not about the pretty level of your curve. because that's where the artistic ability comes in my opinion. Okay? I'm grading based on, did you set up your graph right? Did you hit the right marks? Did you, I don't know, I have a feeling it's sounding intimidating. I don't want it to sound intimidating, but
I can do it.
The only thing is, I feel like you were supposed to take learning when it comes to certain things, and I don't know why, whenever I don't have a pretty looking graph.
So essentially, if we have the gist of it, we'll